Okay, we're talking about logs. And here's how they use logs a lot. They use logs because a log graph, if I graph log, it looks kind of like this. Do you see how it's slowly rising? Scale of like, up to, not, it doesn't go very high, but it goes a long ways this way. And the point is, if you had, for instance, earthquakes that are a million times bigger than other earthquakes, you don't want to have a Richter scale that goes from 1 to a million. I mean, actually, that wouldn't be that bad. That'd be kind of cool. This was a 990,000 on the Richter scale. But the Richter scale goes from 1 to 10. See, it scales things that are huge amount, huge ranges to a small range. Okay, that's the basics of what you use them for. So decibels, for instance, are based on logs. To get that there's incredibly quiet sounds that you can hear but just barely, and there's other sounds that are incredibly loud. And you might have a huge range there from a jet, making a noise, or an explosion making a noise that's so loud that it damages your hearing, like we were hearing on those Starkey videos there. Or you got noises that are so subtle that they say that the Zen masters can hear grass growing. All right, well, anyway, if you have a huge range like that, logs can narrow it down. There's a huge difference in the acidity of things. So ammonia, milk of magnesia, there's not too many like really common things in here that are on the base end of the scale. What's 7 considered? Neutral or normal, okay? And neutral is probably safer. And if you have water, water is usually in this zone. It says from here to here. And if your tap water is probably in that range, 6 to 7. And milk's about the same, but milk is slightly acidic. A long time ago, when people would have the acid in their stomach, which is incredibly acidic, it's actually, the acid in your stomach is right up here with battery acid. If you could just take an eyedropper full of acid from your stomach and put it onto the carpet, it would burn a hole in the carpet. It's that acidic, and it's inside of you. How is that possible? Your body's amazing at its ability to contain that acid and to let the acid break down your food for you and yet not burn a giant hole in you. It's a pretty amazing system. When that system breaks down, though, that's when people get ulcers. Basically, it's a hole that's being burned in your stomach. And they thought that they would tell people to drink milk because they thought milk would coat their stomach. And so the doctors for a long time, oh, you've got an acid problem. You need to drink milk. Milk will make it feel better. Look at which end of the scale milk is on. It's on the acidic end of the scale. They're actually saying, here, drink some acid. That'll make you feel better. It turns out milk was not a great idea, and they do not recommend that anymore for ulcers. Okay, anyway, the pH scale, based on logs. The Richter scale, like for earthquakes, based on logs. So logs have some point in the world. And here's where we would use them. I'd like you to just get to this slide, show your work, and solve all of these that you can. I don't expect you to use a calculator. So in other words, just leave your answers as fractions or square roots or whatever you need to do. That's a good question. No. That brings up what we're trying to show you here is you know how to do this, this, and this, but you don't know how to do that. And that's what logs are good for. Okay, you should have said x equals 5. Raise your hand if you had that one right. Okay, good. Otherwise, we got to move you back to class. Divide by 2, x equals 3.5. That one should have been pretty easy also, or 7/2 would have been a good answer. On to the next one, square root, x equals square root of 7. Wrong. Yes, and I hope most of you caught that on the test, because if you didn't, it was wrong. On to the next one. If you have a 2 to the power of x, it's like, I don't know, but you can get that in two different ways. One way is kind of cheating, but I keep on bringing it up to you because it's the best way to solve weird equations. It uses a graphing calculator, and what do you think you'd do? Graph what, though? Okay, this is what I keep telling you. You got to remember this now. It actually is useful. Graph both sides and see where they cross. Make this one a y and make this one a y. Make this one y1, make this one y2. See where they cross. Go ahead, do it. Graph it. Use a calculator. Put it into the y1. Say y1 equals 2 to the power of x. 2 caret x. And then make y2 7. And hit graph. This is a very powerful way to solve equations that you would have on, like, for instance, the ACT test. All right, now how do you actually see where they cross? Yep, second, calculate, which is above trace. Calculate the intersect, which is number 5. And then if you only have graphed two things, which is smart, you just hit enter, enter, enter. And it'll jump right to where they intersect. Do you see that they intersect x equals 2.807? All right, now the only downside to showing you that is that this kind of, my old argument was you have to know logs to solve that problem. But you really don't, because you can graph both sides and see where they cross. But logs are another way that you can solve this problem right here. Okay, and I'm going to teach you that today. So we spent the last couple weeks working with exponentials, and you can still, use change of base to solve these problems, but only if we happen to use nice numbers. Like 2 to the x equals, what's 32 really? 2 to the what? 2 to the 5th. You remember how we did that? And now you can solve that one because I happen to use a nice number. All right, and because now the bases are the same and x equals 5. But if I said 2 to the x equals 31, it wouldn't have worked. See what I mean? Logs can solve all of these. All right, now but the next one. 9 to the x equals 1/3. I would make them both have a base of 3. 3 squared to the x equals, how do I make a 1/3 into a 3 to the something? 3 to the negative 1. And then the bases are the same, so that equals that. Do you remember doing those? Okay, now what's different is that we could make this 9 to the x equals 1/7, and a log could solve it easily. So, 2 to the x equals 7. How do we solve it with logs? Let me show you. If I were going to write this with a log, this is an exponent. This is a base, and this is the answer to the question. Again, base, exponent, the answer. All right, so here's how I rewrite this puppy as a log. Log, base, everybody do this on the yellow slide. Log base 2, and notice it's like a subscript. It's lowered down. Log base 2 of 7 equals x. And that, my friends, you can enter in the calculator. It's a good question. 7 is not an exponent. So this is a special, this is not 2 to the 7th at all. This is log base 2 of 7, and that's the right way to say it. Now, how do you put that in your calculator? Grab your calculator, and unless you happen to be one of the 2 people in the room who have the super updated operating system, if they can just enter it as you see it, log base 2 of 7. But you'll know it if you've got that because you've got a brand new calculator basically. Okay, if not, then here's how you enter it. You have to do what's called a change of base, and I've got a lot more explanation on this on Tuesday or on Monday of next week, but all you have to do is really draw a line right there, and then you do log of 7 divided by log of 2. Log of 7 divided by log of 2. Everybody grab your graphic calculator, hit log 7. Divide by log 2. Enter. And what did you get? 2.807. Now let's think about this for a second. What that means is if I put 2 to the power of 2.807 right there, it should equal 7. So try that. Take your calculator. Type in 2 to the power of, which is the caret thing, 2.807. Hit enter. Yeah, exactly. Pretty much 7. And why isn't it perfect? Because we rounded the other number. So, of course, this shouldn't work out perfect. If we rounded the 2.807 from something else, then, of course, it's not going to be exactly 7, but pretty much 7. All right. If you really understood that, you should be able to rewrite this as a log and solve it using your calculator. Really important to rewrite it as a log first. Do not just jump right to your calculator. Write it out. Log base what of what. Because see, your calculator isn't even supposed to be used until tomorrow. I'm just trying to show you how these things work, and I needed you to have the calculator to prove that we aren't just making up this 2.807 thing. So you should have said log base 4, because that number is the base number, of 9. And then when you actually type in the calculator, say log 9 divided by log 4, and what do you get? 1.585. Okay, and that means that if I put 4 to the power of 1.585, then I should get about 9. All right, that's what logs do. And they undo a variable exponent. All right, so if you have, of course, 3 squared is equal to 9, if you rewrite that as log base 3 of 9 equals 2. I don't know if you noticed this, but when we do these, you have to jump around. You have to go from here to over to here and then back to here. That's an important thing to understand because I'm going to make you practice rewriting these things. All right, now put your calculators away. We're not going to use them again until tomorrow. I just wanted to show you the basics of how you can use the calculator. Put it away. Calculators away. Some of you still have them out. Please get rid of them now. All right, so if you had this, you can rewrite it as a log. We already talked about that. And this is the base. This one has an official name too. That's called the argument. All right, and you just need a name for that number because that's the base, that's the argument, and then the answer to it is the exponent. So some people feel really strongly about this part, and so I need to tell you this. A log is an exponent. Now, just those words don't really, there's no magic there, but it is true that anytime you are doing a log problem, you are figuring out an exponent. Let me show you what I mean. Log base 2 of, let me think, 8 is equal to 3. If a log is an exponent, that means this is the log part, and it is an exponent, and that's the exponent that it is. 2 to the third equals 8. You get how I rewrote that? This to the that equals that. Or log base 2 of 8 equals 3. Okay, so I want you to take this one. Log base m of p equals k, and rewrite that as an exponent problem. A problem that uses exponents instead. Because in this right now, there are no exponents right now. But if you rewrite it in a different form where it doesn't have a log anymore, it'll be an exponent problem. Did you have m to the k equals p? Raise your hand if you had that on your paper. Okay, good. Then try this one. Log base 6 of x equals 4. Rewrite that one. A log problem is an exponent problem because the 4 is the exponent, and that's what this whole log is equal to. The 4 is the exponent. So Mr. AH, tell me what to write. All right. And unless you can do 6 to the 4th in your head, which is pretty unlikely, at least without a lot of longhand work, that's an okay way to leave it. All right. So, what is the base on this problem? 2. What is the argument on that problem? All right. What's the base on this problem? What's the argument on that problem? And the base on this one. And the argument is, all right, square root of 25 is 5. Very good. Okay. Now, I want you to see if you can figure out in your head what the answer to this one is. No calculator. Raise your hand if you've got it. 4 of you have it. Maybe 5? Okay. Mr. L, tell me what to do. What do you think we should do? Perfect. You just rewrote it. 2 to the x equals 8. There wasn't an x, but you knew that you should put an x for something you didn't know. That was awesome. 2 to the x equals 8. And then you just have to figure it out. 2 to the what is 8? And the answer is what? 3. All right, this one. That's weird. Can you at least tell me the equation? Everybody, write down what you think the equation is for the middle one there. Write down the equation that you think we should use to solve the middle one. Okay, you should have said 1/3 to the power of x is equal to 27. Doesn't that look a lot like those problems we just did in the last test? And you'd rewrite the 27 maybe as 1/3 to the something. Or maybe we rewrite both of these and say, I'm going to rewrite this as 3 to the something, and I'm going to rewrite the 27 as 3 to the something. Go ahead and solve it using that method. Make them both have the same base. Then their exponents will have to be the same. So you got to figure out what exponent to put here and here to make this thing work. And then you'll set the exponents equal. All right, 1/3 and 3. A lot of people still don't get this, so help them out. How do you write 3 and 1/3? I mean, 3 to the what? 3 to the -1 makes 1/3. Okay. The other one's a little easier. 3 to the what makes 27? 3. And that means now the bases are the same. So that equals that. Negative x equals 3, so x equals -3. Raise your hand if you had that one right. Okay, good. Moving on. So the key really is to be able to rewrite these. Take a look at this one and that one and make sure you get how that works. Did you get how those rewrites can happen? All right. Try rewriting that one as an exponent problem, and try rewriting that one as a log problem. I'm going to ask for 2 different people without any volunteers. I'm going to call on 2 different people to give me answers for this, so be ready. Pause for a second. Okay. 2 to the 5th equals x. And so what was the answer then? 32 is right. All right. Next one. Miss G over against the wall. What did you have for that one? Log base 4. Nope. You did a classic mistake. You don't ever do them in the same order that they're in. You have to jump around. Makes me feel like that Crisscross song is about to start playing. All right, that goes over there, and that goes over here. Okay, so 4 to log base 4 of what equals what? There you go. That one's right. Okay, so here's the next phase. I'm going to show you how to do this the slow way, and then I'm going to show you how to do it the fast way. Here's the slow way. These don't have any x's in them, do they? So I can set them all equal to x, and then I can do a rewrite. 3 to the x equals 81. And then I can get the common base thing and all of that. Okay, and I would end up getting an answer of 4. But let me show you the fast way. If you can get this part right here to be 3 to a power, that way the base and the argument have the same base, then the answer will be the exponent. So you just have to say to yourself, 81 is really 3 to the what? Now I know that's not a super simple one, but it's 3 to the 4th. So if this is 3 to the 4th, here's the pattern. If you have something like this, log base 3 of 3 to the 4th, the answer is the exponent. Let me show you why. Let me show you why. Would you agree there's no x here? And therefore I could say equals x. Now watch me do a rewrite of this. 3 to the x is equal to 3 to the 4th. Get what just happened? Same bases, therefore same exponent answer, and therefore whatever's up there is the answer, isn't it? So let's do a few of these other ones. This one. Let's write that one as 10 to the what? 10 to the 3rd, or is it 10 to the, I think it's 10 to the 4th, isn't it? How about if I do this? Would you agree 10 to the 4th is 1 times 10 to the 4th? It's the same thing, right? And doesn't that mean move the decimal over 4 spots? Ergo, that is 10 to the 4th. Okay, log base 10 of 10 to the 4th, what's the answer? 4. All right, this is a little trickier, but we can rewrite that puppy as 5 to the what? Negative makes it flipped 2. Good. And now what's the answer? -2. See how much faster that is than having to write an equation, and then rewrite the equation, and then find common bases, and it takes forever. This is fast. As long as you can rewrite that as 7 to a power, what's that? 7 to the what? Yep. So this is log base 7 of 7 to the 1/2, and therefore the answer is 1/2. This one might give you some trouble. How do you rewrite -4 as 2 to the something? You can't. You are correct. You might think you could find a way, but you can't. 2 to a power can't equal -4. You can't take a number and make it negative by using only the power. So, what does that mean? There is no answer. So what does that mean? Not extraneous. That would mean I found an answer that doesn't work. No solution is correct. You could say no solution. You could say that this it's kind of like undefined, kind of like having a 0 in the denominator. It's just one of those things you can't do. And know why? Because these numbers right here, these numbers there and there always have to be positive. They can't even be 0. They always have to be positive. Yes, sir? Good question. They don't like multiply by each other, so they wouldn't cancel, and therefore, no. So the domain is like the rules on what you can be. The domain on this thing is all positives. The number at the end, the exponent, which if you rewrite it, it'll be the exponent in exponent form. That number at the end can be anything. But this number and this number have to be positive. Remember that, because it's like the easiest answer in the world if the question's like this. You don't have to even think. What's the answer? No solution. Yes. All right, this one, because square root means 1/2 power. If you haven't caught that yet, it's true. Because remember, the roots are on the bottom, and that's the second root, also known as the square root. Okay, this is the one I left off because I have, it's kind of weird. If I rewrite this and put an x in here and do a rewrite, it's 8 to the what equals 1. 8 to the x equals 1. Good. What's x got to be? 0. This is a property that's important. That's a 1 that's in the argument spot. I have a way of you remembering that this always equals 0. It's one of the ones that comes up a lot. If you've won the argument, you get nothing. And it's true. A lot of times, if you and your friend are arguing about something stupid and you win the argument, all you've done is tick off your friend. You might lose your friend over a stupid argument about what's more powerful, a liger or a blue whale. And now, you've won the argument, but you got nothing. Okay. So, by the way, the blue whale is far more powerful. Okay. So, let's just do a little 4-question quiz. They're on the board. See if you can answer those 4 questions. This is time sensitive, so try to finish up in the next 30 seconds. Mr. W in the front row, what do you think number 1 is? Say C. The argument is in that spot. You are correct. Who had that one right? Okay, good. Let's go to Mr. SS in the back row. An exponent. Once again, proving that all teachers like to put C as the answer. All right. How about Mr. DE for this next one? A. You say A. And you have the base of 5, and you have nothing as the exponent because we don't have an answer for it. Good. Equals X. You got it. It was A. And the last one is number 4. Let's go with Miss AB in the pink. What do you got for number 4? Was that B as in boy or B as in boy? Okay. So let me check. How could I do this one? I could rewrite this one as 1/4 to the x is equal to 16. Because I could say equals x here. And 1/4 to the x equals 16. That's what I was doing there. And are you saying that if I put 1/4 to the 4th power, that it will equal 16? You're really close, but you're not exactly right. Because 1/4 to the 4th isn't 16. Kind of got the 4 and 4 thing going, so it seems like you get 16, but you don't. Who's got a different answer they think is right on that one? Mr. H. C. Once again proving teachers love C. So if we have a C in here, it's a -2. You're saying I could put this to the -2nd. If you do that to the -2nd, would it really equal 16? How many of you agree with him? You are correct. Good job. If you were too chicken to raise your hand, shame on you. All right. So this one's got kind of some jargon that I want to make sure you understand. The base here is just showing you that this little base is the same as that base. They are the same. The exponent, which was the answer to this thing, goes in the exponent spot here. And the argument is the one that's at the end in this form. And the argument's that number in the middle of the log problem. Okay. And if you're going to say this, amazing number of kids can't say logs right. So I want to just see if you can say this correctly. I want you to write that out in words on Notability, exactly how you say it. Exactly. No extra words. I'm trying to prove a point here. Math is kind of precise, if you haven't noticed that yet. Seriously, I have kids that at least a full grade lower than they should be, just based on negative signs. It's really, really picky. Have you ever, I don't know if you've ever done any computer programming, but if you have one decimal, one colon in the wrong spot, the computer cannot understand you and it won't work. The program will fail based on one Literally one period in the wrong spot. All right. Now I want you to turn your iPad towards someone sitting near you. I'd like you to go this way. I'd like you to turn yours towards her. And you're going to be looking at somebody else's screen and see if they're exactly the same as you. If not, decide who you think is right. I will give you the final word. Has everybody checked with somebody? I know it's one person that didn't. Boo. All right, anyway. This should be said. Log base 3 of x. Now this is the part where you could either say is or you could say equals 42. Who had it perfect? All right, only 4 people. All right. Do you get my point? If only 4 people in the room were saying it correctly, it is a common problem for people to say these right. All right, I'm going to write one more, and I want you to write it correctly. Write it in words correctly. Not a huge deal. You can get problems right without saying it right, but you know, if you don't know how to say it, you don't sound like you know what you're talking about. I remember when I first was learning about engines, and I saw that written on a car engine. There's one way it makes total sense. There's another way that makes you seem like you don't know what you're talking about. And I'll ask you for that one in a second, too. All right. This one. Log base x of 1/5 is, or equals, 29. How many had it right this time? Okay, good. Now, how about that forced CYL thing? Forced cylinder, okay. Any other nominations for what you think that means? Forced cycle? Okay. Have you ever heard of a 2-cylinder engine? Ever heard of a 4-cylinder engine? Ever heard of a 4-cycle versus a 2-cycle? All right. So you can see how that could be, you know, if you say that the wrong way, 4-cylinder versus 4-cycle, you could see how somebody might think, okay, this guy doesn't know what he's talking about, because they're totally different things. 4-cylinder engine actually has 4 cylinders in it, okay, and that means cylinders are like the pistons. Okay, so this is like saying I have a 4-piston engine. Versus 4-cycle, there's 2-stroke and 4-stroke. There's all kinds of different kinds of engines, but we're talking about how many cylinders it has. So 4-cylinder was the correct answer. All right, moving on. Oh, these are just some fun factoids, so don't really need those. You can peruse them if you'd like. And we are done with learning about logs. You have a homework assignment, which is about logs, surprisingly. So go find that worksheet. And that's all I have for the video for today.